Okay, this is section 2.4 from Math 120, average rate of change. So what we can do here is we can take a graph of a function and look at how much the y value changes as the x value changes. In this case, we have t for your x and distance is s for your y. They want the average speed from 1 hour to 4 hours. So they're talking about this interval right here. And then how much does your distance change over that time interval, which is this distance on the vertical axis. So your average rate of change from T1 to T4 is just going to be your change in your distance divided by the change in your time. Change in your distance is 150, and the change in your time is 3 hours. So we would say the average rate of change is 50 miles per hour. Okay. Now we can also look at a different interval. Let's look at this second one, when time is 0 and when time is 2. So the first 2 hours of this trip has the interval on the x-axis from 0 to 2, and the corresponding change of your distance is going to be found by looking at your y-coordinate, and I'm going to say that's equal to 90. All right. So the average speed from time 0 to 2 is going to be the change in your distance divided by the change in your time. So the change in your distance is going to be 90 miles, and the time is 2. So in this case, they went 45 miles per hour on average in the first distance, in the first 2 hours. So notice what we can do here is think of this as just slope. For the blue, for this particular rate of change, that was the rate of change from time 1 to time 4, and all we did was find the slope of the line that connects those 2 points. For this particular rate of change, we did time 0 to time 2, and we can see the line connecting those 2 points. One might say that the blue line is a little bit steeper, so you would have a higher rate of change in that time interval. So if we were to do this in general, let's take any particular function. In this case, I'll just draw a smooth curve. And on this function, we have x coordinate. Let's call that x1, and another x coordinate x2. There is a corresponding y value for each one of these. So we have the coordinate x1, f of x1. And we have the coordinate x2, f of x2. So if I want to find the rate of change, the average rate of change, it's going to be the line that connects these 2 ordered pairs. And that's nothing more than slope. So the average rate of change is equal to f of x2 minus f of x1 divided by the difference of the x values. And you might recall from your geometry that this is nothing more than y2 minus y1 over x2 minus x1. We can also get an average rate of change from a table. In this case, an object is dropped from rest with travel a distance of 16t squared, where t is the number of seconds and the object falls is dot. So if we want the average speed in the first 2 seconds, we're just looking for how much the distance changed, which is 64, divided by how much your time changed, which is 2. So the average rate of change is 32 miles per hour. Looking at the second interval, the first 3 seconds, the distance changes 144 feet, and the time changes 3 seconds. So I think that's 48 miles per hour. Once again, we see 2 different rates of change because it's not a linear pattern. Here's another example from a graph. If I were to have a graph of f of x equals x minus 3 quantity squared, it wants me to find the average rate of change from 1 to 3. And that's going to be this line right here. One thing we can see here is that the ordered pairs for this point is going to be 3, 0, and then, let's see, 1, comma, 4. So your average rate of change is going to be the change in your y, which the y increases from 0 to 4, and the change in your x, which increases from 1 to 3. So then your average rate of change is the change in the y, which is going to be 4, divided by 2, and we get 2 for the average rate of change. Now, make a note here. We should have a negative number because it's going downhill. So let's think of this slope as going down 4 to the right 2. So this average rate of change is actually negative 2 because your y's are decreasing and your x's are increasing. Okay, let's do an example where we have an expression, a function. Let's go f of x equals x squared minus 4, and let's find the average rate of change. And let's go from -1 to 3. In this case, they give you this. We'll call this x1. We'll call this x2. And with the formula, we're just going to plug this in. It's f of x2 minus f of x1, and then we'll divide that by x2 minus x1. All right. So plugging x2 into this formula, I'm going to get f of 3 minus f of -1, and we'll divide that by 3 minus -1. So we have to find the y coordinate when x is 3. So let's see, I'll put that in blue, and so that's going to be 3 squared minus 4. I have to find the y coordinate when x is -1. I'll put that in red, and so we're still subtracting that. That's going to be -1 squared minus 4. So that is the top part of this slope formula, and then we'll divide that all by 3 minus -1, which is 4. What we have now is just arithmetic. Let's go ahead and take 3 squared minus 4, that's 5, and then I'm going to subtract, let's see, -1 squared minus 4 is -3. And we're going to divide that by 4 again. Well, 2 negatives make a positive. That's 8 over 4, which is 2. So we would say that 2 is the average rate of change for this particular function from -1 to 3.